In this video, we're going to talk about division of complex numbers. So the division of two complex numbers, z1 and z2, bears some similarity to their multiplication. So writing the quotient in component form, we obtain z1 over z2 being equal to x1 plus y1i over x2 plus y2i. So in order to separate the real and the imaginary components of the quotient, we just have to multiply both the numerator and the denominator by the complex conjugate of the denominator here. So let's go ahead and do that. So we will have z1 over z2 being equal to x1 plus y1i over x2 plus y2i. Then this multiply the conjugate form of this denominator. So s2 minus y2i. The same thing applies to the denominator part. So this multiply the conjugate form of itself, s2 minus y2i. Then you just go ahead and you expand it. So when we expand it, we should get x1 x2 plus y1 y2 plus x2 y1 minus x1 y2 over x2 s squared 2 plus y2 squared. This is what we should get. Then when we do it, try to factorize or group like terms. When we try to group like terms, we should get x1 x2 plus y1 y2 over s squared plus y squared. So this x is 2, this y2 is y2 squared plus the I. So this is the imaginary part. Then x2 y1 minus x1 y2 on s2 squared plus y2 squared. So this is what we are gonna get. So let's take example 1. So example 1, we have z being maybe x plus I y, where z here is 3 minus 2i over minus 1 plus 4i. So when we try to do this, you know how we do it. Multiply the conjugate form of the denominator by both the numerator and the denominator. So we should get the multiplication of minus 1 minus 4i. This also multiplying minus 1 minus 4i. And when we do it, we should get minus 11 minus 10i over 17. Then grouping like term, we have to get the imaginary part, we have to get a real part, so we just group it and get negative 11 over 17 minus 10i over 17. Then we are done. Now let's take note of these properties. So when you see something like this, z1 over z2, this property should be also equal to z1 over z2. And you know what this sign is, right? The argument of complex. So when you're asked to find the conjugate of the division of two complex numbers, you can first find the conjugate of each of the complex numbers, then you divide it. It's the same thing. You can also find the division of the two complex numbers, then you find the conjugate of each. is also the same thing. Anyhow you do it, that's what this property is saying. Another property is when you have the argument of z1 over z2 is also equal to the argument z1 minus argument z2. Also the same thing. Just take note of this properties. It's very, very important. Now let's take another example. So let's say we have example 1. We have 3 minus I over 2 plus 7i. Let's write this in a standard form. So with the standard form, you should get 3 minus I multiplying the conjugate of the denominator, which is 2 minus 7i divided by 2 plus 7i multiplying the conjugate of itself, 2 minus 7i. And when we do it, we should get 6 minus 23i plus 7i squared over 2 squared plus 7 squared. And we should get minus 1 minus 23i over 53. And lastly, should group them into the real part and the imaginary part. We should get negative 1 over 53 minus 23i over 53. You can also try this on your own. 3 over 9 minus I. Write it in the standard form, and I'll see you in my next video. Thank you for watching this video.